Picture this. You're out on an afternoon stroll when suddenly you find yourself surrounded by hundreds of ants, all running in a tight circle. They're not marching in perfect unison like soldiers on parade. No, they're engaged in a frantic, never-ending race around a clearing. And right in the middle of this bizarre anthropolis is something small and shiny, maybe a bit of foil or a tiny bead. It might seem like a weird scene from a sci-fi movie, but it's actually a real-life phenomenon that's been observed in various ant species across the globe, and it's known as the death spiral. So what exactly is going on here? Why are these ants stuck in this seemingly pointless circular dance, and why does it often end in tragedy for the little creatures? To understand the death spiral, we have to look at some basic features of ants. First, ants primarily rely on their sense of smell to navigate the world around them. Instead of visual landmarks or a magnetic compass, they use chemical trails known as pheromones to figure out where to go. Pheromones are essentially species-specific scents that ants can lay down as they move through the environment. These scents act like a message saying, "Hey, I was just here, come follow me." Now, this is a pretty great way to find food or figure out the way back to the nest. If there's a trail of ants leading into the underbrush, it's probably a shortcut to a juicy meal or a quick route home. There's no need for each ant to plot its own course through the woods when someone else has already done the legwork and marked the way. That is until something goes wrong with the trail. Like what happens if the trail loops back on itself? Say some ants have found a food source, but the trail they're following leads them in a circle around a tree before heading back to the nest. Now, if the ants don't realize they're doing a full circle, they'll just keep on following the scent. After all, it makes sense to follow the ant in front of you unless it takes a sharp turn and then immediately starts heading in the same direction again. In a way, these ants are like those plane passengers who follow instructions and end up right back where they started. But unlike that unfortunate flight, the ants don't get a second chance to get their bearings. They're trapped in a death spiral. But why do these ants remain oblivious to their circular journey? Why don't they question the trail they're on? Well, the answer lies in the next feature of ants that makes them susceptible to the death spiral, and that's their lack of individual decision-making. Ants aren't known for their complex thought processes. Their behavior is mostly hardwired or instinctive. Once an ant finds a trail, it follows it. When it comes across another ant, it either avoids or, if necessary, fights the other ant. But in most cases, an ant doesn't really think about what it's doing. It just reacts to stimuli in the immediate environment. So if an ant is following the trail and the ant in front turns around, the following ant will simply do the same. This lack of independent decision-making means that when one ant turns, the next ant on the trail will do the same, and the next and the next. It's like dominoes, but instead of rigid wooden blocks, it's a bunch of little insects glued to a pheromone trail. In normal circumstances, this lack of individuality isn't much of a problem. Following the leader works well for ants, especially since they usually have a clear goal in mind, like finding food or getting back to the nest. But this same lack of individuality becomes a fatal flaw when the trail they are following leads them in circles. Since no individual ant questions the trail or the ant in front of it, once the colony begins circling, there's nothing to stop them from keeping on circling. It's a classic example of what scientists call a positive feedback loop. Each ant simply does what comes naturally, follow the scent, and keep moving. And that action reinforces the very thing that's guiding it, the chemical trail. This brings us to the third reason ants are prone to the death spiral: amplification. Let's say you're at a party and you notice a group of people standing in a tight circle, laughing and pointing at something in the middle. You're curious, so you approach the group to see what's so funny. Maybe it's a magic trick, a hilarious joke, or a baby. But when you get closer, you realize it's just a coin. A boring, unremarkable coin sitting in the center of a circle of people. What's going on here? Why are all these people gathered around something so mundane? Well, this is a real-life example of an amplification effect similar to what happens in the ant death spiral. People are drawn to the crowd because of the crowd itself. The more people you see gathered together, the more likely you are to assume that whatever they're looking at must be interesting. And the more people who arrive, the bigger the crowd gets, which reinforces the idea that the gathering must be important. Pretty soon, you have a bunch of people standing around something that might not be all that interesting on its own, but the fact that so many people are paying attention to it gives it a kind of inflated importance. The same thing happens with the ant death spiral. The chemical trail that the ants are following is like the crowd at the party. It's a simple, natural phenomenon that's only noticeable because so many ants are paying attention to it. The more ants that join the spiral, the more the chemical trail is reinforced, which makes it stronger and more attractive to more ants. This creates a vicious cycle. The trail gets stronger because more ants are walking on it, but the ants keep walking on it because it's already strong. It's like a game of telephone where the message gets distorted with each passing, but here the message is a chemical trail and the distortion is a circle. And while this positive feedback loop might seem like a good thing for the ants, like when they're marching toward a food source, it becomes a deadly trap when the trail leads them in circles. This looping trail acts like a black hole in space. The more mass that enters it, the more the gravitational pull strengthens, making it even harder for anything to escape. And the more ants that fall into the spiral, the harder it is for any single ant to break free. The weight of numbers makes the spiral stronger, so if one ant tries to veer off course, it's likely to just get pulled back in by the collective momentum of the group. And this brings us to the final and perhaps most tragic consequence of the death spiral. Because ants don't have a built-in GPS or a watch to tell the time, they don't know how long they've been circling. They're trapped in an endless now, doomed to repeat the same action over and over. They might circle for hours or even days until they're too exhausted to keep going. Eventually, the ants die, not from a single decisive blow or a battle with a predator, but slowly and tragically from exhaustion, worn down by their own momentum. Sometimes, thousands of ants can be trapped in a single spiral, forming a macabre mosaic on the forest floor. Now, in nature, these spirals are rare, but they show how collective behavior, which is usually advantageous for the colony as a whole, can sometimes become deadly for the individuals. And the ant death spiral also offers a lesson for us humans. We often marvel at the complexity of human society, our ability to build cities, write symphonies, and launch spaceships into orbit. But these achievements are made possible by simple rules followed by countless people. We make decisions based on information we receive from others, reinforcing patterns of behavior that can lead to both great things and terrible ones. Understanding the dynamics of these systems, the feedback loops and amplification effects that drive collective behavior is crucial. It helps us navigate the world more effectively, whether we're trying to solve a global crisis or figure out what to wear on a first date. The ant death spiral is a reminder of this. It shows that simple rules followed by countless individuals can lead to complex, sometimes tragic outcomes. But it's also a reminder of the resilience and adaptability of life. Even in the face of disaster, life finds a way to not only survive, but also thrive. In the case of the ants, they continue to march, albeit in circles, and their colonies persist despite the occasional tragic spiral. Thanks for watching.